So next on the docket are the components. So up here, so you go into, at the highest level, game objects. And then we'll close all these just to make it a little bit easier to read. So game objects. Everyone is a scene component. This is what I'm moving towards. Everything in our engine that is going to be in this scene is going to be considered a scene component. So this is going to be used more next quarter, but you'll see it kind of referenced throughout some of these objects, but not fully implemented yet. So for starters, we have the input. Now this one's a little weird. So I was experimenting with splitting it. So I have the mouse input component and a keyboard input component. I was trying to see if maybe this could make it easier of adding unique functions that would be unique to only that specific one. So like a mouse input component has like get mouse position X and Y, where the keyboard component does not. And that way I also can unsplit what kind of types they use. So if you go to input, see the mouse only has these 6 options where the keyboard has everything on the keyboard. I was trying to see if that would make it a little bit easier for the user. As of right now, I'm not entirely sure if we benefit a lot from it, but that's the way our engine works. So there's the inputs, input components, and the mouse input component manager. And all the managers live on the scene object, who lives in the scene manager, yada yada yada. Mouse input component manager, manager. And these key state observers, that's how if you go in the manager, I'm tracking everyone, all the different types of keys. When you go into process inputs, just anyone who's tossed into the active list is put in there. So when you go to the parent, they have a ref counter, and then you have the key monitor and the action monitor. Action monitor is how like a user-defined event happens. So if you go down to engine settings, image layers, actions, there you go. So in this case, we defined move forward, move backward, move left, move right, and swap scene. So all of the action monitors would be relating to those. So if you go in the keyboard input manager, he has an array of actions and an array of keys. So whatever you bind an action, what he's actually doing is registering himself into a keyboard, into a keyboard key monitor in this case. And that's why the ref counting comes in handy, is if no one is bound, if no keyboard input components bind themselves to an action, it will not bind itself to a key. And because a key doesn't have any references to him, he'll never put himself into the active list, so he'll never be checked. Because that's all it's doing, is it's going through the active list and then just updating their state, which will alert everyone in those lists if they're anyone relevant. And then the mouse is the exact same. Honestly, I'm betting there's some ways I could merge this nicely, but for now, it was just cleaner to separate them. Mouse is the exact same thing, just with smaller arrays. Because mouse currently only has left to right, middle, x1, x2, and then the actions. And then also, you'll notice these functions called the bind action. Key bindings are actually kept outside of any of the one managers. That's kept on its own binding manager outside of it. Here you go, the input manager. Input manager is where bindings are actually stored. Yeah, he has the array for all the bindings. So whenever you change scene or you change one of the bindings, the scene will then tell its relevant managers to rebind to match like the latest view. So that way, the input manager is a singleton, so it keeps the bindings scene independent. So if you had like a like a player controller that has a bunch of input components that were listening for move forward, and you wanted to bind move forward to like the W key, that binding would hold across scene 1, 2, 3. It would never change as long as you didn't change it. So that's why this is a singleton, where the others are scene-based. Because the scenes are a specific object. This guy just wants to hold the info. Okay, next are the updates. Updates, super simple. Update component. LCNO sees a scene component. Update component, yada yada yada. Yeah, they do nothing. I haven't fully implemented the scene component because I was experimenting with adding unions to try to make my commands easier. And it was a cool exercise, but I found it was actually more difficult than just creating another layer of inheritance. by having the scene component, and then everyone just piggybacks off of this register into scene child. That's just the way it should be done. And then we have update manager, exactly what it sounds like. He just lives on a scene, and he holds just a list of updates to refer to. This guy is a little bit more complicated because I was experimenting with splitting this information. Honestly, it just became a list. There's some information that I was ripping out of the update components and putting them into an array of headers. And so that way all of your header information is stored in the manager itself, instead of having like scattered linked list of information across all the components. This was an interesting idea, but I found it was more work than necessary. If I could templatize this, it would be worth it. But as for right now, it was a cool experiment, but I haven't done any performance analysis to see if it was worthwhile, and it was just a pain in the butt to make. Alarms. Keyboard. Alarm. Alarm component. Classic thing from last quarter, set alarm, stop alarm, but with a little added spice of get time remaining. This one just, he tracks his time endpoint and then he compares it to the current scene's time, if you ask him. If you're not registered, he'll just give you 0. Besides that, he's very, very standard. Yeah, the get time remaining was useful for particle system type things. Alarm manager, exactly what it sounds like. Process alarms, register, deregister. This is where I was intending to use the priority queue, but I was not entirely happy with how flexible and useful my priority queue is going to be. I will need to do more testing to see if maybe it's actually worth just sucking it up and just doing it, if the performance is worth it. So for now I'm just using a multi-map, which I know isn't great performance-wise, but it works fine. It got our stuff working. And then not listed on the objectives document is the collision system. This was originally, I was thinking about adding a little Boyd's demo, but I found that was just going to be a huge pain in the butt. But the collision system I could add fairly quickly. So we have a collision component here, who's also another seed component. And if you see, this guy's actually using his scene components properly. So register in scene child. Whenever the scene component calls this, that's the parent object of scene component, it'll pass the scene that he wants to register into, and then he just gets the collision manager and registers himself. I love that way more than what I was doing with the unions. So highly recommend do not touch unions for commands. I think this is the way to go. Okay, so collision components have start detecting collision, stop detecting collision, and then you can set what volume they use. Right now we only have planes and spheres. I didn't want to spend a ton of time on this, so I just made the quickest one that we could work with next quarter. Set world, you can get collision volume. And here's just information for when you set your collision volume. I'm actually pooling the collision volume objects themselves are actually owned by the collision manager on the scene. So all of that is actually pooled away. So we get a nice little resource sharing of all the collision components. Then you go into the volumes here. We have our collision volume. This is using just the standard visitor pattern. You call collide accept, and then there's the 2 visits. One for planes and one for sphere. We went a little fancier with passing the you pass the other. So that way when you go into the collision component, when you go into the collision, you get the who you hit and his collision volume, which we found was really useful for getting the bouncing balls to be able to bounce off each other, because you needed the to get the other object's information. And then you go into sphere. Now I'll probably split these functions, the collide visit, into like a collide visit test and an actual call for collision, and then a theoretical test for collision. Because I put them together so I could do this. So you can pass the other component nicely, so you get all the typing through the visitor pattern. And then, yep, information for updating a sphere. Sanitizing, because we are pooling these objects. So what we do is anytime you get rid of whenever a collision component gets rid of his current collision component, he sanitizes it and then puts it back in the pool. Plane, exact same idea. Manager, We didn't do anything fancy here. He just goes through all the objects in there and does the awful embedded loop. So the n squared over 2 classic, just, yeah, it's not ideal, but it does the job. And it wasn't on our bracket, so I'm happy that it got in there, and this should serve us well for next quarter. And that's all of, I believe that's all of our components. We can